Right, today's video is on double angle formulae. Right, so what are the double angle formulae that we are going to learn? If you look at what is written on the screen, we'll be learning sine 2a, which is equals to 2 sine a cos a. So for cos 2a, you will see that there are three different formulas, right? It can be expressed as cos squared a minus sine squared a. Okay, cos squared a, what does cos squared a means? It means cos a multiplied with another cos with a. And in this case here, you can just write it as cos squared a, right? You can also express it as 2 cos squared a minus 1 or 1 minus 2 sine squared a, right? And the double angle for tangent 2a will be 2 tangent a over 1 minus tangent squared a. So how do we make use of the double angle formulae? We can use it to evaluate trigonometry expressions. We can use it to prove trigonometry identities and also to solve trigonometry equations. Right, so the double angle formulas are actually derived from the addition formulae. So how does it work? Right, so let's recall what this addition formulae for sine. So if you have sine bracket a plus b, it's equals to sine a cos b plus cos a sine b. Then how are we going to make use of this to find our double angle? Right, so what we're going to do is we're going to replace the angle B with angle A. Right, so I would end up having sine bracket A plus A on the left hand side. And then on the left hand side, if I replace all the angle B with angle A, I'll end up getting sine A cos A plus cos A sine A. Right, so cos A sine A, you can write it as sine A cos A. How is that possible? We can just use this example to illustrate it. If you have A times B, right, the result you get would be the same as B times A. Right, this is called the commutative law. So what happened? You will see that you have sine A cos A plus another sine A cos A, and that will give you 2 sine A cos A. So your first double angle formula will be sine 2A equals to 2 sine A cos A. And we're going to do the same, all right, to derive the double angle for cosine. So we will begin by using the addition formula for cosine bracket A plus B, which is cos A cos B minus sine A sine B. Right, we're going to use the same process, replace angle B with angle A. So we end up getting cos 2A on the left-hand side. And on the right-hand side will give us cos squared A minus sine squared A. Now, so you recall that we actually have three different formulas for cos 2A. So on the next slide, we are going to derive the other two. All right, so before we can derive the other two formulas for the cosine 2x, right, we have to make use of the Pythagoras identity that we have learned earlier. The very popular one is your sine squared x plus cos squared x equals to 1. And from there, we can actually find sine squared x to be 1 minus cos squared x. Or you can actually find cos squared x, which is equals to 1 minus sine squared x. So what is the purpose of doing that? We shall see. Right, if you're going to substitute equation 1 into your cos 2x, you're going to replace your sine squared x here with 1 minus cos squared x. Let's see what happened. Right, take note that you have to bracket it. Yes, and you end up getting 2 cos square x minus 1 on the right hand side. So this is the second formula that we have come across in the earlier slide. And similarly, if you're going to substitute equation 2 into your cos square x minus sin square x, in this case here, you replace your cos square x with 1 minus sin square x. You end up getting 1 minus 2 sin square x. So you get the third formula for cos 2x. Right, so we're going to do the same to derive the double angle formula for tangent 2a. Right, so we start off by writing the addition formula for tangent. We do the same step as before, replace angle B with angle A, so we will get tangent 2A on the left hand side. And on the right hand side, you get 2 tangent A over 1 minus tangent square A. So this is how we actually derive the double angle formula using the concepts of addition formula. Right, before we go on to apply the concepts of the double angle formula to solve some problem sums, we need to understand the meaning of this thing called double angle. What does double angle means? Right, so if we look at sine 2a, sine 2a is equals to 2 sine a cos a, right? So you can see that this angle A on the right hand side is actually half of 2A. Or you look at it the other way around, the 2A on the left hand side is actually twice the angle on the right hand side, or double the angle on the right hand side. So let's have another example. If you have sine 4A, right, so 4A is double 2A. That means 4A is, 4A is equals to double of 2A. Right, so on the left hand side, if you have sine 4A, it will be equals to 2 sine 2A cos 2A. Right, so you see that you involve only the angle. It's only the angle on the right hand side is half the size of the angle on the left hand side. Supposing if you have another example that says sine A, right? So if you have sine A on the left hand side, then that will be equals to 2 sine A over 2. Okay, because A over 2, it's half the values of A on the left hand side. And if you have sine 6A, it will be equals to 2 sine 3A cos 3A. Right, so remember, double angle, only the angles are affected. All right, the values here 2, it remains the same. There's no change. Right, it's only the angles that's been affected. So let's do another example. Supposing if I have sine 4A, we have already done sine 4A. Let's do another one. Let's say if we have some huge number, sine 100A, so that will gives you 2 sine, half of 100 will be 50, so 2 sine 50A followed by cos 50A. So let's say if you want to, if you have cosine 4A, let's say if you have cosine 4A, then what would that be? Okay, if you have cosine 4A, that will be 2 cosine squared. So half of 4A will be what? How much is half of 4A? 2A, right? So that will give you 2 cosine squared, 2A minus 1. One formula, or it can be 1 minus 2 sine squared, 2A, or it can be cos squared, 2A minus sine squared, 2A. All right, let's put our knowledge into practice. Let's look at example 1. So we have given that A is an acute angle. Acute angle meaning A is between 0 degrees and 90 degrees. And then the ratio for cosine A is square root 3 over 5. Without using a calculator, when you say without using a calculator, it means that you're not expected to find the values of A. You're not expected to cosine inverse square root 3 over 5. Okay. And you're asked to evaluate the following. Find the values of sine 2A and also sine 4A. Alright, so if A is an acute angle, then which quadrants do you think A can be found? Yes, it's between 0 to 90, so it can be found in the first quadrant. So we will draw a right angle triangle in the first quadrant. Right? Right, so cosine A, so square root 3 over 5 is the ratio for cosine A. And to find the ratio for cosine A, it's the length of the adjacent side divided by the length of the hypo. So let's label the angle A first, and let's label all the 3 relevant sides. Alright, so let's fit in the length for the opposite side, which is square root 3. Oh, sorry, adjacent side, which is square root 3. The hypo will be 5. And to find the opposite side, we will use Pythagoras theorem. Alright, so Pythagoras theorem, a squared plus b squared equals to c squared. So therefore, it's equals to c squared minus b squared. So we can find the opposite sides to be square root 22. Right. So the next step is to write down the double angle formula for sine 2a. Oh, sorry, before that, from the diagram, we can find the sine ratio, which is opposite over the length of the opposite sides over the length of the hypo. In this case, it is square root 22 over 5. Right, then you write down the formula, the double angle formula for sine 2a, which is 2 sine a cos a. Then you plug in the values for sine a, which is square root 22 over 5. Plug in the values for cos a, which is square root 3 over 5. Alright, you're not expected to use a calculator, so you have to use the rules that we have learned in the chapter on thirds. So square root 22 times square root 3 will give you square root 66. And then, of course, 5 times 5 will give you 25. Right, so this is how you solved a questions using the double angle formula and also using Torcaso to express your trigo ratio in a right angle triangle. Alright, so from part 1, alright, we have managed to find the answer for sine 2a, also the answer for cos a, and the answer for sine a. Right, so for part 2, let's write down the double angle for sine 4a. So that would be 2 sine 2a cos 2a. Okay, remember that the angle on the right-hand side, will be half of the angle on the left-hand side. So half times 4a is 2a. Hence, your sine 4a is 2 sine 2a cos 2a. Alright, so you have found the values of sine 2a from first part. However, to find the values for cos 2a, we will have to use the double angle formula for cos 2a. So let's do a recap here. Alright, the double angle for cos 2a will be, yes, the 3 formulas there. Right, so which one to use? You can use either one of them, but of course we would want to use one that not so complicated. So I will not choose to use the third one. I would choose to use either 1 minus 2 sine square a, because I've already got the values for sine a, or use 2 cos square a minus 1. Okay, and because you're not allowed to use, I mean, when you say do not use a calculator means you have to show your working, right? You're not expected to get an answer that is an irrational form, right? So you have to leave your answer insert. So as the result, you will have to work this out. Square root 3 over 5 times another square root 3 over 5 will gives you 3 over 25. Then, of course, you can use a calculator to work out this part here. Here, which will gives you negative 19 over 25. Right. And then, of course, you can use a calculator to multiply 4 times negative 19. That gives you negative 76. But you leave the square root 66 alone. Don't use a calculator to work it out. All right. So you should leave your answer in the search form. Right. So with the knowledge gained from the example one, I think doing CW1 will not be that difficult, right? Because the concept involved is the same, right? A is in the cube angle, so angle A should be in the first quadrant. And we are using Torcaso. Torcaso can only be applied in the right angle triangle. So let's draw it in the first quadrant, right? And then you label your angle A. Okay, if you're not too sure how to draw triangles in the relevant quadrants, okay, you just draw a cross first. All right, and then just draw a ribbon like that. So in the first quadrant, this is how your triangle will look like. In the second quadrant, you'll be look like this way. Third quadrant, fourth quadrant. Because sometimes the questions given to you is such that the A may not be a cube. Right, sometimes the question given is A is an obtuse angle. So if A is an obtuse angle, then you will have to draw it on the second quadrant, right? Yes, you have to draw it on the second quadrant. Okay, right. So it's good practice that you, even though A is in the cube angle, it's good practice to draw the diagrams using the 4 quadrants and not just simply draw a right angle triangle like that. Okay. All right. So the next step is just to label your angle A and then label all the 3 relevant sides, opposite, adjacent, hypo, and then put in your ratio. For tangent A, the ratio is the opposite sides over the adjacent side, which is 4 and then square root 3. Then as usual, use Pythagoras theorem to find the hypo, which turned up to be square root 19. And then you can just label it. Right. Okay, part 1. All right. So from the diagram, you will be able to find the sine ratio and also cosine ratio. Right. So you need these 2 ratios to solve part 1. Okay, so they are basically like what I mentioned earlier on, the 3 formulas to use. I have chosen to use 1 minus 2 sine square A. All right, you can use 2 cos square A minus 1. You can also use cos square A minus sine square A. Right, the only thing that you have to watch out on is for this fraction, you would have to, you can't use a calculator, so you will have to solve it, without using a calculator. Multiply numerator, 4 times 4 is 16. Then square root 19 times square root 19 gives you 19. So that gives you 16 over 19. Then of course, this one here, you can just use a calculator to help you. And then just leave your answer as a rational number, as a fraction. All right, so for part 2, okay, we have to find the double angle formula for cos 4a. Right, so half of 4a is 2a, hence the angle on the right-hand side will be 2 cosine squared, 2a minus 1. You Right, so cosine squared 2a means cos 2a means times another cos 2a, right? That actually give you cosine squared 2a. Okay. If you do not want to use 2 cos squared 2a minus 1, you can also use 1 minus 2 sine squared 2a, or you can even use cos squared 2a minus sine squared 2a. Well, of course, this is not a good choice because you do not have values for sine 2a. So this is not a good choice. So it's either this guy. Oh, sorry. So this is also not a good choice because we do not have value for sine 2a. In part 1, we only managed to find the value for cos 2a. So therefore, this is the only choice left. Okay, unless you want to go and find the value for sine 2a, which I don't think yeah, it's necessary, it's efficient. It's not efficient, right? Because if you want in exam, there is this thing called the time constraint. So we don't want to do anything that it's doesn't help us to get the answer as soon as possible, right? Okay, right. So we can sub in the values for cos 2a, which we have found it earlier on in part 1 to be negative 13 over 19. And then, of course, this one you can easily use a calculator and then leave your answer as a rational number. All right, so for this homework questions, right, shouldn't be too difficult. Right, so the steps involved are, again, A is in the cube angle, so it should come from the first quadrant. And then you have to draw the right angle triangle in the first quadrant, label the angle, label all the 3 sides. All right, used Pythagoras theorem to find the unknown side. And then the next thing is to write down the double angle formula for tangent 2a, right? And then from there, you can solve for part 2, which is tangent 4a. Okay, so then the double angle formula for tangent 4a will be 2 tangent 2a, 1 minus tangent squared 2a. So remember, it's only the angle that is being affected. All right, the rest remain the same. Right, so just sub in the values for tangent 2a and then use a calculator to work it out, leave your answer as rational form. Rational means fraction form lah. Okay, so it's not difficult. Right, so sometimes you need to use double angle to solve questions, proving questions, right? So in example 2, you need to prove the identity cos 3a equals to 4 cos cube a minus 3 cos a. So when you do proving identity, you usually prove from the left-hand side. That means you work from the left-hand side, do a lot of manipulations, and finally you get the answer that is given on the right-hand side. Or it can be the other way around. That means you start with the answer given on the right-hand side, do a lot of manipulation, blah, 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 and finally arrive at the answer that's given on the left-hand side. So in this case here, we're going to start with the left-hand side because we have more. We can actually write 3a as 2a plus a, and then we can apply the addition formula. Okay, now, so after applying the addition formula, then you realize that this one here, it's double angle. This is also a double angle, so we can just apply the double angle formula for cosine 2a and also for sine 2a. All right, very, very careful. You need to bracket this. Okay, just you need to bracket it because if you don't bracket it, then the whole idea is not the same anymore. If you don't bracket it, what you're getting is something like this. Right. It means what you're getting is just 2 cos squared a minus cos a, which of course is not, the intent is not the same really. All right. Okay, so let's erase off. Let's not learn the wrong thing. Let's learn the correct thing. So very important, make sure you bracket it. Okay, so what's the next step? Yes, so why do we use 2 cos squared a minus 1? Yes, of course you can go on to use 1 minus 2 sine squared a also. Alright. But I will not advise you to use cos squared a minus sine squared a. Okay, because it's I think cos squared a minus sine squared a, it's more confusing. So try not to use that lah, unless you really have to use it. Alright, so the next step is that we open up the bracket. If you have difficulty, like opening up the bracket, what you can do is you can just shift cosine a, put cosine a in front of your bracket. You know what I mean? If you're one of those that you can only expand, when this guy is when the simpler term it's on the left side of your bracket, then you just shift it to the front. Because after all, a times b, is the same as b times a, right? So it doesn't matter. Just shift it to the front, then it will be easier for you, to do the expansion. All right. So likewise for this guy here also, you can rearrange it into 2 sine a, then multiply with another sine a, and then cos a. Okay, so sine a times sine a will give you 2 sine squared a, and then times cos a. All right. Okay, but you see that we are still not getting the answer that is needed on the right hand side. Right, we still have to get rid of this guy here. Okay, have to get rid of this guy. So hence we will have to use the Pythagorean identity that we have learned earlier. Alright, so sine squared a is 1 minus cos squared a. So I'm going to replace my sine squared a with 1 minus cos squared a. Yeah, so again, what I've done here is I actually have rewrite it as 2 cos a then times sine squared a. Okay? Alright, and then substitute sine squared a to be 1 minus cos squared a, and then you expand. Right, expand the bracket here. Right, to get negative 2 cos a and then plus 2 cos cube a, and simplify again. You have 4 cos cube a minus 3 cos a, which is what is required of you to solve on the right hand side. Alright, so based on the knowledge that we have learned earlier on, right, so earlier on, what we have done is we rewrite cos 3a as cos bracket 2a plus a, right? The purpose is to apply the addition formulae, right? Then after applying the addition formulae, we use the double angle formula. So we're going to use the same concepts here in CW2. Right, so the first step is that we're going to start proving from the left-hand side. Okay, so like what I've mentioned earlier on, we rewrite 3a as a plus 2a. Okay, and then we apply the double angle formula. The addition formulae. The addition formulae for this guy here, which give us sine a cos 2a plus cos 2a sine a. Right, then we apply the, what do we do next? Then we apply, we factorize common term. So what is the common term that I can factorize? Yes. So can you see that I have a sine a, and then I have a sine a cos 2a. So I can actually factorize the sine a out from these two guys here. So that will give us sine a bracket cos 2a plus sine a. And then I shift, all right, this guy here, I put it at the last term, as the last term. And of course, the denominator remain the same as 2 sine 2a. All right, so what do we do next? We can apply double angle formula. for this guy. Okay, so right, so it's so when it comes to cosine 2a, it's a bit tricky. Why a bit tricky? Because cosine 2a is troublesome lah. Cosine 2a has three formulae to work on. All right, it can be like 2 cos squared a minus 1 minus 2 sine squared a, or cos squared a minus sine squared a. So we need to decide which one to use. All right, so the simple rule to go by is the one that I use, right, will help us to simplify your term. You understand what I'm saying? So if you're going to use, let's say, 1 minus 2 sine squared a, okay, 1 minus 2 sine squared a and then plus 1, you end up 2 minus 2 sine squared a. Okay, so it did not actually simplify it. You start off with two terms, cos 2a plus 1. Cos 2a is one term, 1 is another term. So you have started with two terms, it still end up with two terms. So it's not simplifying thing for you. All right. Similarly, for your cos squared a minus sine squared, if you use that, even worse. From two terms, you end up three terms. Right. But if you were to use 2 cosine squared a minus 1, let's see what happened. Yeah, your 2 cosine squared a minus 1 plus 1. Can you see that you actually get rid of your 1? Minus 1 plus 1 give you 0. So from two terms, you simplify into one term, which is 2 cosine squared a. So this is the kind of trick aim that you should try to achieve. Okay, when you do proving, you should always try to simplify things rather than complicate things. That means if you're given two terms, try to reduce it to one term. Given three terms, try to reduce it to two terms or one term. All right, so what's the next step we do? Yes, we split it up into two fractions. Right, so from one fractions, we split into two fractions. Then you'll be asking me, why is it I know that I should split into two fractions? So this one really come from doing a lot of practices, because it's through experience, trial and error. You try the first method, doesn't work. Then you try another method, right? And then you realize that in some situation you need to split into two fractions, some situation you don't need. Okay? So do not be afraid to try. If you get it wrong, just try. All right. Okay, so from there, we apply double angle formula for sine 2a, which is 2 sine a cos a. And we can do a lot of simplification here. Sine a divided by sine a gives you 1. Cos squared a divided by cos a will just left with cos a. And then 2 divided by 4 will gives you half. So do the same thing also for this guy. So you have cos a over 2 plus cos a over 2. And that will gives you cos a, which is what you need to prove on the right hand side. All right, so to do homework 2, all right, we start with the left hand side. So cotangent 2a is 1 over tangent 2a. Okay, so what we're going to do is, if you look at tangent 2a, we can apply the double angle formula. So always go back to the basic. The basic is look at the formula. Look at the formula and see which one I can use. So the best is that to have all these formulas, internalize it, everything inside your head. Internalize it so that when you look at the questions, you know which one to pull it out. So for tangent 2a, right, the double angle for tangent 2a will be 2 tangent a over 1 minus tangent square a. Okay, so 1 divide, and then you change the division to multiplication, you flip your fractions. Okay, simplify it. All right, so in this case here, you have to combine them into one single fractions. Okay, and then you can simplify it to get 1 plus tangent square a. And then 1 plus tangent square a, if we were to do a recall, it's one of the Pythagorean's identity that gives you secant square a. Yes, some recall there for your double angle for tangent 2a, and also your Pythagorean's identity. Right, so we can replace your 1 plus tangent square a with secant square a. Right, and then what is secant square a? It's actually 1 over cos square a. And what is tangent A? It's actually sine A over cos A. Right. Then you do. Okay, so if you look at this proving questions, right? If you look at this, all the questions we have done so far, right? You realize that if you do not make friends with the formula, if you do not memorize the formula, you will find trigonometry very difficult. Because if you do not remember that 1 plus tangent square A is secant square A, you will not know how to substitute 1 plus tangent square A to be secant square A, right? And if you do not know that secant square A is actually 1 over cos square A, then you can't move, right? So in order to do trigo well, you must make an effort to memorize all this formula and then practice and practice and practice until you gain enough experience to know which steps to apply. So this involves a lot of hard work. Right, so let's look at example 3. All right, so it's double angle formula again for tangent 2A. Right, so this is like solving an algebraic equation, except now that it involves trigo. So do a cross multiply. Whatever you learn for your algebraic equations, algebraic fractions, the concepts are still the same, except now that you are just dealing with trigo function. All right, so we will end up having a quadratic equations involving trigo functions. Okay, and you factorize it. If you are not too comfortable in factorizing trigo quadratic equations involving trigo, you can always use substitution, as in like you can let tangent A equals to the letter x. So your quadratic equations with trigo function will end up to be 3x squared plus 8x minus 3 equals to 0. Okay, and then you can just factorize it. This one will look familiar to you. So x can be 1/3 or x can be -3, and then put back your x to be tangent A. Okay, you can use this method if you're not too comfortable in factorizing quadratic equation involving trigo functions. All right, so the next step will be tangent A equals to 1/3 or tangent A equals to -3. All right, so we need to determine which one is our answer. And to do that, this information is very important. We need to make use of the information given there. It says that the angle 2A is between 180 to 270, so that will be in the third quadrant. So from there we can find angle A because we are interested. We have tangent A. What we are interested in is angle A, not 2A. So to get A from 2A, you just divide both sides by 2. Right, so you end up A is between 90 to 135, and that's in the second quadrant. So from your ASTC, you can see from ASTC, in the second quadrant, only sine trigo ratio is positive. So your tangent of any angle in the second quadrant must be a negative value. Hence, your answer will be tangent A equals to -3. And we reject tangent A equals to 1/3 because your answer must be a negative value. Because we're talking about tangent of an angle in the second quadrant. All right, so you use the same reasoning, the same skill, right? The same skill that we have learned in the earlier slides. Put down the double angle formula, all right, and then factorize it. Simplify it, cross multiply, simplify, you get a quadratic equation. All right, so this is harder than the earlier one because this quadratic equation, you would need to use quadratic formula. So how do you know when you can factorize it and when you need to use quadratic formula? Basically, in the questions, you will have some scaffolding. Like the earlier questions, right? You asked to find tangent A only. But in this question here, you are told that to leave your answer, to leave tangent A in cert form. So if you see this thing called cert form, means your answer is not an integer. All right, it's not a rational number. I shouldn't say integer. It's not a rational number. It's not like 2/3, half, or 1 or 2, -3. It's not a rational number. If it's in cert form, means you will have to use the quadratic formula. Okay, anything that you see this cert means you have to use your quadratic formula to factorize it. Okay, to find the values of tangent A. Right, so from the quadratic equations involving trigo functions, you write down the values of A, which is 1, B is -5, C is -1, and then we use your quadratic formula to help you find tangent A. Alright, so you end up again having two answers, one positive, one negative. So again, we need to decide which one is our answer. So end up angle A is in the second quadrant. Alright, so tangent will be negative in the second quadrant. Okay, under your ASTC. So therefore you reject tangent A equals to 5 plus square root 29/2. Alright, so to summarize, the concept involved here is apply the double angle, do a cross multiply, get a quadratic equation involving tangent, involving the trigo functions. Right, if the question says find something in cert form, then you have to use quadratic formula because your answer would not be exact. Otherwise, you can usually factorize it to get a rational number. Okay, I should not bore you with all the details for CW3. All right, after the first few slides we have done, you would have enough confidence to be able to do CW3 on your own. So can you see again that you're supposed to find tangent A in cert form? Cert form means it's not exact, so we have to use quadratic formula to factorize your quadratic equations. All right, let's use the double angle formula to solve some trigo equation. Let's look at part A. Right, so what is the double angle formula for sine 2x? Yes, it will be 2 sine x cos x. Right, and that will give us 6 sine x cos x. Right, some of you will attempt to divide by cos x on both sides. Please don't do that, because if you were to do that, you're actually eliminating one possible set of values for x. So a more accurate way of doing would be to put everything on the left-hand side. And observe that it's a common factor here, which is cos x. So what do you do with the common factor? Yes, we apply the concepts of factorization. So you factorize cos x. Right, so here you will apply the zero product rule. So we would have cos x equals to 0, or 6 sine x minus 5 equals to 0. Right, so that will give you sine x equals to 5/6. So what we have here are two simple trigo equations where you can just solve it as per normal. What is as per normal? Right, we find the reference angle first. So if cos x is equals to 0, reference alpha will be cos inverse 0. Cos inverse 0 will give you 90 degrees, but we don't leave your answer in degree, because if you look at the range that is given to you in the questions, it's supposed to be between 0 to pi. So 90 degrees, if you convert it to pi, it's pi/2. Right, so if you look at the ASTC, For cosine to be positive is first and the fourth quadrant. Right, so from there, x can be pi over 2, the first quadrant, or the fourth quadrant, which is 2 pi minus your alpha, which is pi over 2. That gives you 3 pi over 2. Oh, but because the range given to you is between 0 to pi, hence you don't need to find the angle from the fourth quadrant. So the only possible answer will be just x equals to pi over 2. Right, so how about the second equation, sine x equals to 5 over 6? Right. Yes, we go on to find your alpha first. So alpha will be sine inverse 5 over 6. And because you have to leave your answer in terms between 0 to pi, you remember to change the calculator, the mode in the calculator to radian mode. Right, and then you press shift sine inverse 5 divided by 6. Right, so that will give you 0.9851. Right, so for sine ratio to be positive, 5 over 6 is the positive value. Right, so the suitable angle will come from first and the second quadrant. Right, so your first answer will be just, from the first quadrant will be just x equals to alpha, which is 0.985. Three significant figure, unless if it's angle in degree, then it's one decimal place. Then the second value will give you pi minus alpha, which is pi minus 0.9851. And that will give you 2.16. Right, let's go on to do part B. Right, so what is the double angle formula for tangent to x? Can you remember? Yes, it will be 2 tangent x over 1 minus tangent square x. And you're going to multiply it with tangent x again. Right, so you multiply the numerator. So 2 tangent x times tangent x will give you 2 tangent square x. Multiply the denominator. All right, and then we do a cross multiply. So that will give us 1 equals to 3 tangent square x. So tangent square x will be 1 over 3. So tangent x will be positive negative square root 1 over 3. All right, so what is the next step that we do? Yes, find alpha. So alpha is an acute angle, so we have to tangent inverse a positive value, which is square root 1 over 3. Okay, and because the answer that is required of you is in degree, so remember to change the mode in your calculator back to DEG, back to degree. So shift tangent inverse, square root 1 divided by 3, and you will get a 30 degrees. All right. Okay, let's go back to the ratio. Okay, it can be positive or negative, meaning all the 4 possible quadrants. But however, the range given to you, it's only up to 270. So therefore, you only need to consider first, second, and third quadrant. You don't have to worry about the fourth one. So the first answer will be x equals to alpha, which is just 30 degrees, first answer. Second answer is from the second quadrant, which is 180 minus alpha, and that is 180 minus 30, give you 150 degrees. Third quadrant will be 180 plus alpha, which would be 180 plus 30 gives you 210 degrees. Right, and we can stop there because the range is only up to 270, up to the third quadrant. Right, let's look at part A. So for part A, we have 7 cosine x equals to 2 cosine 2x. Now, even though we said that to solve a trigo equation, we just make sure that we're dealing with one trigo function. In this case here, we still cannot solve it in the sense that on the left-hand side is cosine 1x, on the right-hand side is cosine 2x. You can either just solve for cosine x or cosine 2x or cosine 3x or cosine 4x, but not a combination. Right, so which one has formula that we can apply on? Right, yes, we can apply the double angle formula for cosine 2x. So there are 3 formulas for cosine 2x. It can be cosine square x minus sine square x. It can be 2 cosine square x minus 1 or 1 minus 2 sine square x. So we have to make a choice here. The choice will actually determine if we can go on to solve the trigo equation. So let's go back to the basic. The basic is that I must generate an equation involving only with one trigo function. So therefore, it is quite useless to use cosine square x minus sine square x to replace cos 2x because you'll be introducing another trigo function. So hence, this has to be eliminated. Likewise, for 1 minus 2 sine square x, it doesn't make sense to use that. So you are left only with this choice, which is 2 cos square x minus 1, where we're going to substitute into our equation. Right, so we're going to simplify it. And you see that we end up having a quadratic trigo equation. All right, so if you're not comfortable in factorizing a quadratic trigo equation, you can always use substitution, meaning you can always let cosine x equals to a letter A, right? So cosine square x, it's just cosine x times another cosine x. And that gives you a times a squared, right? So you end up having 4a squared minus 7a minus 2. And I'm very sure you'll be able to factorize this quadratic equation involving algebra. All right, so we will have 4a plus 1 equals to 0, or a equals to 2. Now remember that a is just a substituted value for cosine x. So the next step is that we will have to substitute your a back to be cosine x. A equals to negative 1/4. Right, so we would have cosine x equals to negative 1/4 or cosine x equals to 2. Now we all know that the maximum value for cosine x is 1, so therefore cosine x equals to 2 is not applicable. So we are left only to solve cosine x equals to negative 1/4. Right, so how do we go about solving a trigo equation? What's the first step? So recall, what's the first step? Yes, the first step is to find alpha. So alpha will be alpha is in the cube angle. So we need to cosine inverse a positive value, which is 1/4. So cosine inverse 0.25, that will give you 75.52 degrees. If you don't get 75.52 degrees, most likely your calculator mode is not set to degree. So please check the mode on your calculator. All right, so the next step is that where are the angles hiding? Is it from the first quadrant, second quadrant, third quadrant, or the fourth quadrant? So the next thing is you have to draw your ASTC. So for cosine to be positive, it must come from first and the fourth quadrant. Hence, for cosine to be a negative, because we have cosine x equals to negative 1/4, the angle will be hiding in the second and the third quadrant. All right, so for the second quadrant will be 180 minus alpha, which is 180 minus 75.52. Now, for your working answer, angle in degree is 2 decimal places, but for your final answer, it should be expressed to 1 decimal place. And that you will get 104.4 degree. So this will be second quadrant. So you go on to find the answer from the third quadrant will be 180 plus alpha, which is 180 plus 75.52. And that is equals to 255.5 degree expressed to 1 decimal place. Right, so this is how we solved part A. All right, let's look at part B. So for part B, yes, we can apply the double angle formula for tangent 2x. Right, so the double angle for tangent 2x would be 2 tangent x, 1 minus tangent square x. Right, so we will have 2 tangent x over 1 minus tangent square x divide by okay, what you can do is maybe you can do cross multiply first. All right, do cross multiply first so that you don't have to deal with all the divide and things like that. So I'm going to take 2 times tangent 2x. So you will end up having 2 tangent 2x equals to negative tangent x. And we're going to apply double angle formula for this guy here. That will give us 2 tangent x over 1 minus tangent square x equals to negative tangent x. Okay, so you multiply numerator, multiply denominator, you end up getting 4. Because 2 times 2 tangent x will give you 4 tangent x. Then over 1 minus tangent square x. Alright, so we still have to do another cross multiply lah. So that will give us negative tangent x times bracket 1 minus tangent square x. Make sure you have your bracket there. Alright, so we would have okay, do not divide tangent x on both sides because then you're eliminating some answer. So what we need to do is we need to factorize it. Simplify first. So you will end up getting tangent cube x minus 5 tangent x equals to 0. And tangent x is a common factor, so you can just factorize it. And we can apply the zero product rule. So you have tangent x equals to 0 or tangent square x equals to 5. Alright, so tangent square x equals to 5 means your tangent x can be positive, negative, square root 5. Alright, so now we have 2 trigo equation to solve. Okay, so to solve trigo equation, we always have to find alpha. Remember alpha. Make alpha your best friend forever. So alpha equals to tangent inverse 0. Okay, you need to leave your answer in degree. So tangent inverse 0 is 0 degree. Okay, then ASTC, first and the second quadrant. So x from the first quadrant will be 0 degree. Okay, so this is a bit tricky here. You can't have 0 degree as the answer. Why? Because tangent 0 gives you 0, right? We can't have this guy here equals to 0. Okay, you can't have this guy equals to 0 because you can't have something divided by 0 that will give you error. So hence, okay, hence, yeah, so hence from this step here, okay, sorry. Right, so I think it's good that I did not, I kind of did not think of that. So from here, all right, I think from here, we can make some conclusions. Okay, we can say that since tangent x cannot be equals to 0, right? Because if you look at the original equation, right, you have tangent 2x divided by tangent x, and then you can't have tangent 2x divided by 0. So since tangent x cannot be equals to 0, right? So you only left with tangent square x minus 5 equals to 0. Okay, so that will give you tangent square x equals to 5. Hence, tangent x can be plus minus square root 5. Okay, so find alpha. Tangent inverse positive. Okay, alpha is an acute angle, so you have to tangent inverse a positive value. So that gives you 65.91. All right, working answer should be two decimal places for angle in degree. All right, so let's look at which are the possible quadrants. If you look at this guy here, it must come from all four quadrants because it can be positive or negative. So if you look at the ASTC, positive will be the first and the third, negative will be second and the fourth. So hence all four possible quadrants. So let's look at the first one. First one will just be equals to alpha, which is 65.9 degree. Second one will be equals to 180 minus alpha. That will give you 180 minus 65.91, and that gives you 114.1. Right, 114.1, and then your third quadrant will be 180 plus alpha, which is 180 plus 65.91. They give you 245.9 degrees. And last but not least, the fourth quadrant, 360 minus alpha, 360 minus 65.91, and that gives you 294.1 degree. Okay, so we've completed worksheet. I think this is worksheet 29. Okay, good job.